Hey, today we're going to talk about 4.1, Plate Tectonics. So before we begin, you can check out the Enduring Understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. So this topic of plate tectonics and other topics throughout this unit may be a review from your earth science content, and if that's the case, great. If you haven't taken earth science, you will learn enough during this topic, during this unit, to get you by and make you successful in AP Environmental. I will tell you right now, I have never taken an earth science course in my life. I've had it maybe in like 8th grade, like parts of it. But I've learned enough about it throughout my career and throughout my life that I can teach you what you need to know. If you have any really hard pressing questions, I may refer them to another teacher, or we can look it up online. So the Earth is made up of several layers. You don't have to know every single one of these layers. In a nutshell, if you think about the Earth representing like an egg, you have the yolk of the egg, and that would represent the Earth's core. You would have the white liquid part of the egg, and that would represent the Earth's mantle. And then you have the eggshell, and that would represent the crust. Now within this, there is an inner and an outer core. You don't really have to know that. There's different parts of the mantle. The outer part of the mantle is the asthenosphere. You don't have to know that. You may see this word again, but you're never going to have to learn how to say it. You're never going to have to learn how to spell it. And then you have the lithosphere. And the lithosphere is important because the lithosphere is formed of the crust and then the solid outer portion of the mantle. If you think about this from the egg analogy, inside the eggshell, there's a little membrane. And this membrane, if you ever crack an egg, you have the shell, which is clearly the shell, but then inside there's a little looks like a little like plastic sheet or something. Crack open an egg and you'll see that membrane. But the eggshell and that membrane would represent the lithosphere if you were following the analogy. Now why does this matter? Because the lithosphere is floating on top of the asthenosphere. So the asthenosphere is very molten, it's very hot rock, and it's melted rock. And the lithosphere is floating on top of it. And this was proposed in a theory called the theory of plate tectonics in the 1800s. I don't know the scientist's name that came up with it. You don't have to know either. But basically we have these convection currents. And convection currents is the movement from hot to cold, basically. We have extremely hot molten rock in the inner mantle. And we have cooler molten rock and solid rock in the crust and the upper mantle. What happens is you have this warm molten rock, and it is rising up. And as it rises up to the Earth's surface, it hits the crust, and it can't go anywhere but pushing out. So what happens is it rises up and it hits the crust and it pushes out. Actually, it hits the lithosphere, and then it pushes out. And when it's pushing out, sometimes it'll grab onto some of that lithosphere and pull it with it. So if you see right here, we got these arrows, and it's pulling this lithosphere back down into the asthenosphere, back into the mantle, where this solid rock will then remelt and form molten rock again. And when this happens, this whole plate of the lithosphere is basically moving around. So it's moving in different parts on the Earth at the same time. So different parts, some parts are moving apart, and then over here some parts are moving together, because this one over here is coming down, so this one is moving to the right, and then if you notice over here, this one will be moving to the left, so they'll be coming together. And sometimes they come together and one goes underneath, sometimes they come together and they push up like a mountain, and I'll show you in a moment. But these convection currents, and you'll notice convection currents also happen in air. So when you heat up air, the warm air rises. That's why hot air balloons rise. That is why smoke rises, because it goes from really warm to really cool. So convection currents just means going from warm to cool. What we see here, we will also see very similar in the atmosphere in a future topic. Now we have different times when these plates may come together. Sometimes the plates run past each other like parallel. So as they're running past each other, this is called a transform boundary. You do have to know there's three different types of plate boundaries. The transform boundary is the highest probability of earthquakes because they slide and then they're not completely smooth. Even though this diagram looks smooth, there's jagged edges and they catch and then they snap. And when they snap, what happens is it releases all of this built up pressure, and that's an earthquake. Transform boundaries are found in California, Los Angeles to San Francisco. It is the San Andreas Fault. Okay, a divergent boundary is actually the most common in oceanic plates, and divergent boundary, just like the word looks like, diverge, you go apart. So this is where the plates are moving apart. So if you remember from the convection current diagram, goes up and pushes apart. Where it moves apart, that is a divergent boundary. So down here we have the convection currents pushing up and then moving this to the left, moving the other one to the right. And what we have is we will have what is called seafloor spreading. And seafloor spreading is when you're basically creating new ocean floor. And this happens underneath in the oceanic plates. And the oceanic plates are basically found at the bottoms of the ocean, and the continental plates are found where the continents occur. If it happens, this divergent boundary happens under the ocean, you get seafloor spreading. If it happens on land, you get a rift valley. So oceanic plates are more dense than continental plates. That's why they're farther down on the Earth's surface. And again, seafloor spreading happens in oceanic plates, and a rift valley would occur in a continental plate. A convergent boundary happens when one of the plates goes underneath when one plate goes underneath the other. The more dense plate will go underneath the less dense plate. So if you have an oceanic and a continental plate, the oceanic plate will always go underneath. If you have two continental plates, whichever one is more dense will go underneath. If you have two oceanic plates, same thing will happen. Whichever one is more dense will go underneath. And what will happen is, as this is moving down, this is called subduction. So when one plate moves below another plate, it is subduction. And what can happen is this plate moves down, and all of this solid rock will now melt, and then it kind of has no place to go. So a lot of times it will form a volcano. It can also form a mountain. And these are very common. Volcanic activity are very common wherever you have convergent boundaries. And I will show you a map in a moment. But you can also have tsunamis. So when one plate is moving under the other plate, again, like a transform boundary, it doesn't go smoothly. So sometimes as it's moving, it gets stuck, and then it releases. And when it releases, if that's happening underwater, that displacement of all the water can cause a massive wave. And a tsunami is basically just a massive wave that can form offshore and can decimate coastal areas. Hugely destructive. There was a tsunami in, I think, 2004, 2006. I'd have to look it up, I don't remember. But it happened in the Indian Ocean and killed like 250,000 people. It was very destructive. It happened like right the day after Christmas. So you can look that. I think it was 2004. And that is very common. Tsunamis are very common. In fact, there was a tsunami in 2011 in Japan that led to the meltdown of the Fukushima nuclear power plant, which we will discuss in the future. We have different types of tectonic boundaries. This green, letter B, this represents where we find transform boundaries. There is a map, and you got a map if you took earth science. It's a hugely complicated map. I'm showing you the ones that you have to know, okay? You will typically have anytime you have an earthquake or mountains, you're going to have a tectonic boundary. So volcanic activity, earthquakes, and mountain formation are going to happen at these plate boundaries. You will also have another situation where you can form volcanoes, which I'll tell you about in a second. So letter B represents a transform boundary. Letters C and D represent where we have seafloor spreading. This is a divergent boundary. And letter D is actually the location of Iceland, which has a lot of volcanic activity, and that's because of the plate boundaries that are found there. Letter E represents where the Himalayan mountains are formed. So historically what happened was India is a separate plate, and Indian plate moved into the Asian plate and kind of came together like a convergent boundary, kind of rumpled it all up, and like a big car accident formed the Himalayan mountains. So the Himalayan mountains are actually the youngest mountain range on the planet, and they're also the highest because they haven't eroded. They're still technically forming because they're still we're not able to see the results of it, but the Himalayan mountains are still growing, and that is because the Indian plate is settling into place. Letter F represents where Japan is found. This is also a convergent boundary, and it is the site of the Fukushima nuclear meltdown in 2011, resulting from a tsunami. Letter A represents Hawaii, and this is where we will see hotspot volcanism. Okay, so what is hotspot volcanism? I'll show you in a second. This is a map of the world. This is, you can see North America. It's maybe a little bit confusing. North America, South America, Africa, Europe, Australia, Asia, China, Japan. Anyway, this area right here that's all red is called the Ring of Fire. And this is because it is a place where we see high levels of earthquake and volcanic activity. So the Ring of Fire is an area, the western coast of North and South America and the eastern coast of Asia and Australia. And this is where we have convergent boundaries, and there is a huge amount of earthquake activity. If you look, all these little yellow dots represent earthquake activity. Notice they're all pretty much found wherever you have plate boundaries, except you got this little thing right here in Hawaii. And now we'll talk about hotspot volcanism. So a hotspot volcano is basically an area where the crust, which is represented by this brownish tan part with the arrows on it, you have an area of the crust that is very thin. So parts of the mantle are able to push up into that crust. And very much like if you have imagine if you had thin layer of your socks, and you can always see your skin through that layer of your socks. And if you put the socks on your hand, you're going to see the skin through the sock because it's very thin, you can see through it. The same thing will happen in a hotspot volcano with the crust because it is very thin. The mantle and this molten rock is able to push through it. So as these plates are moving across the mantle, what's going to happen is this molten rock is going to be able to push through because it's very thin. What happens is you're going to form a volcano. So this is a hotspot volcano, and this happened in Hawaii. And you notice it happens where there's no other plates around, or there's no other plate boundaries. So it's just this random volcanic formation. And then what happens is this keeps moving, and now this volcano is now dormant. It is no longer active because it's no longer receiving or doesn't have access to this this magma. And then what happens is this part is now thin, and you're going to push through and form another volcano. So these plates are constantly moving. So what happens? Same thing happens again. You're going to form another volcano. And this will continue to happen. And sometimes, depending on how long the plate has been over this thin area, this hot spot, you'll have different sized islands. Typically, and this diagram doesn't show it, but typically the older islands are going to be larger and the newer ones are going to be smaller. If you look at the Hawaiian Islands, they go in a string. If you look at the Galapagos Islands, that's another area where we have hotspot volcanism. There's like a chain. If you look at the Aleutian Islands at the tip of Alaska, that's another spot where we have hotspots. Also in the Canary Islands off the coast of Africa. That's another area, and I actually got to go to an island a couple years ago on spring break. I went to the Canary Islands, and I was on an island that was literally only 10,000 years old. So it was formed by volcanism, and it had already started ecological succession. It was really kind of cool because there was already spots that had soil formation. If you remind me, I can try to find the pictures and show you in class. Okay? But right now, let's practice. Take a look at this map. All right, so I would like you to explain how subduction can lead to volcanic activity. I hope that this video was informative. I thank you for your attention, and I will see you soon.